Today, we're taking you inside a supergiant recycling plant where mountains of discarded wood are collected, sorted, shredded, and pressed into particle board. A material that has quietly become the backbone of modern construction and furniture making. Before we dive into this fascinating journey, make sure to like, subscribe, and hit the bell icon so you won't miss more behind-the-scenes stories of how the world's most essential materials are recycled and transformed. The story of particle board begins during the early 20th century, a time when the world was searching for cheaper and more efficient building materials. In Germany, 1887, engineers first experimented with bonding small wood particles using natural adhesives. But it wasn't until the 1940s, during World War II, that particle board as we know it today truly took shape. With raw timber in short supply, German inventor Max Himmelheber patented a process in 1941 to create boards from wood chips and shavings, materials that were once considered waste. His invention opened the door to producing strong, affordable panels without relying solely on solid lumber. Today, the world's largest particle board plants can recycle millions of tons of wood waste every year, turning what was once landfill material into durable boards used in homes, offices, and commercial spaces. Our journey begins with the arrival of truckloads of wood waste. Every single day, semi-trailers packed with discarded pallets, old furniture, shipping crates, and demolition waste pull up at the gates of this enormous plant. In the United States alone, more than 12 million tons of wood waste is generated each year. Instead of letting this wood pile up in landfills, plants like this give it a brand new purpose. Once the trucks unload, the wood is spread out in huge open yards. Here, workers and machines begin the process of sorting and grading. Clean wood, free of paints, chemicals, or glue, is separated from contaminated material. Nails, screws, and metal brackets are removed using giant magnets and metal detectors. The clean wood is stacked aside for the next stage, while unusable scraps are either burned for energy or disposed of safely. This careful preparation is critical, because particle board requires uniform, clean fibers to achieve strength and consistency. A single piece of contaminated wood could affect the entire production batch. After sorting, the wood moves into massive shredding machines. Picture enormous steel drums with razor-sharp rotating knives capable of chewing through wood at lightning speed. The shredders break the wood into chips and splinters, reducing bulky pallets and furniture into small, manageable pieces. These wood chips are then sent through another stage of grinding, where they're further reduced into tiny flakes and fibers. The goal here is consistency. Every fiber needs to be about the same size, so the final board has even density and no weak spots. Next comes drying. The wood fibers are sent through long, heated conveyor dryers. Here, powerful hot air removes excess moisture, reducing the content to about 2 to 5%. This step is crucial. Too much moisture would cause the board to swell and crack later. By the end of this stage, the plant has transformed thousands of tons of bulky wood waste into a fine, uniform raw material, ready to be turned into something new. Now comes the science that turns loose fibers into a solid board. The dried wood fibers are mixed with synthetic resins and adhesives. Inside huge blending drums, jets spray a mist of resin onto the falling fibers. The resin acts like glue, bonding the particles together when pressed. Some plants also add wax to improve moisture resistance. This mixture is carefully controlled. Too much resin makes the board brittle, too little makes it weak. Engineers constantly test samples to make sure the ratio is just right. Once mixed, the fibers resemble a soft, fluffy carpet. But the magic is about to happen. The resin-coated fibers are spread out evenly onto a moving conveyor belt, creating a thick mat of loose material. This mat can be several inches thick and many feet wide. From here, the mat passes through a giant hot press, one of the most impressive machines in the entire factory. Under intense heat, up to 400 degrees Fahrenheit, 200 degrees Celsius, and enormous pressure, hundreds of tons, the wood particles and resin fuse together. The mat is compressed down to the thickness of a board, usually between half an inch to an inch thick. This pressing process doesn't just flatten the fibers, it actually transforms them, melting the resin and bonding everything into a single solid sheet. The heat sterilizes the board, while the pressure ensures uniform density. When the press opens, what was once a loose pile of waste fibers has become a rigid, durable particle board panel. Freshly pressed boards are still hot and flexible, so they move into a cooling system. Giant fans and conveyor lines gradually bring down the temperature, allowing the boards to harden fully. Once cooled, the boards are trimmed to precise sizes using high-speed saws. The rough edges are cut off, leaving clean, uniform panels. Next, the boards are sent through industrial sanding machines. Sanding smooths out the surface, making it ready for laminates, veneers, or direct painting. At this stage, you'd be surprised how professional and finished the boards already look. What started as broken pallets and furniture is now a stack of sleek, standardized particle boards ready for use. Before shipping, every batch undergoes strict quality testing. Engineers check for density, ensuring the board is uniform, moisture resistance, simulating exposure to humid environments, strength, pressing and bending tests to mimic real-world use. Only boards that pass all these tests are packaged and sent to customers. So, where do these boards go? Particle boards are used in furniture, desks, wardrobes, cabinets, flooring, underlayment beneath carpets and tiles, construction, walls, partitions, shelving. They've become a backbone of affordable modern living, and all from waste that might have ended up in a landfill. And there you have it, the incredible journey of wood waste as it's transformed into durable particle board inside a supergiant recycling plant. If you enjoyed this behind-the-scenes look, don't forget to like, subscribe, and hit the bell, so you'll never miss another fascinating story of how the world's most essential materials are made, recycled, and transformed. In a handful of modern recycling factories across the US, broken bottles, shattered windows, and piles of glass waste are getting a brand new life as colorful, durable tiles for homes, offices, and even luxury hotels. In today's video, we're going to take you inside one of these factories and show you exactly how trash becomes treasure. From the moment the glass arrives to the moment the finished tiles are packed and shipped, you'll see every step in the journey. And trust me, it's way more fascinating than you think. Before we jump in, if you love discovering how everyday things are made and how waste can be turned into something amazing, go ahead and hit that subscribe button and turn on the bell. We post fascinating behind-the-scenes stories every week, and you don't want to miss what's coming next. All right, let's head inside the factory. It all starts with mountains of glass waste. Every single day, trucks pull up to the factory loaded with recycling bins, giant bags from construction sites, and crates from municipal collection programs. This isn't just beer bottles and soda jars, it's everything. Old mirrors, cracked windshields, broken tabletops, even glass from demolished buildings. If it's glass, it can be recycled. At the gate, every load is weighed. The weight, the source, and the type of glass are recorded. That way, the factory can track exactly where each batch came from. It's like keeping a paper trail, but for glass. Here's the thing about glass waste, it's never just glass. You've got bottle caps, plastic labels, bits of ceramic, maybe even a stray fork or two. All of that has to go. So the first stop is the sorting line, Workers stand along fast-moving conveyor belts, pulling out big contaminants by hand, anything that could jam the machines or ruin the tiles. Next, the glass passes through high-tech separators. Air jets blow away lightweight trash like labels and paper. Magnets remove any metal, like jar lids or steel bottle rings. Screens and sifters shake out small stones or dirt. Then comes the washing stage. Imagine a giant industrial dishwasher. Jets of water blast away leftover liquids, sticky soda residue, and fine dust. After this bath, the glass sparkles. Some factories sort glass by color at this point: clear, green, amber, because it makes it easier to control the final tile color. Others keep it all mixed for a more speckled mosaic look. Now the clean glass heads to the crusher. This thing is a beast. Huge spinning hammers smash the glass into small chunks called cullet. If you've ever dropped a glass and seen it break into thousands of tiny pieces, this is the same idea, except controlled and consistent. The pieces are usually between the size of a pea and coarse sand. Why crush it? 2 reasons. 1, smaller pieces melt more evenly later in the kiln. 2, it's easier to mix with other ingredients when it's fine. The finer the glass, the smoother the final tile surface will be. For some designs, they even grind it to a powder so fine it feels like flour. Crushed glass alone can't hold the shape of a tile. It needs a glue to bind it together. This is where binders and additives come in. The cullet goes into massive mixing drums, along with clay or porcelain powder, gives the tile strength and structure. Pigments, or color. Want a bright cobalt blue kitchen backsplash? That's thanks to a pinch of mineral pigment. Fluxing agents. These lower the melting point of glass so the factory can save energy when firing. The recipe is like baking cookies. A little too much of one ingredient and the whole batch turns out wrong. Technicians carefully measure each component to make sure every tile looks and performs exactly the same. Once mixed, the material feels a bit like damp beach sand, gritty but moldable. Here's where the transformation starts to get exciting. The glass mixture is fed into tile presses, huge machines that slam down with tons of pressure, squeezing the mix into perfectly flat, square shapes. These presses can pump out hundreds of tiles per hour. For more artistic or decorative tiles, the mixture is poured into molds instead. Some designs even sprinkle in bigger chunks of colored glass at this stage, so when the tile is fired, you get gorgeous jewel-like specks inside. When they come out of the press or mold, the tiles look, well, kind of dull. They're just pale, chalky shapes. But that's about to change in the kiln. Freshly shaped tiles are still damp from the mixing process. If you put them straight into a hot kiln, they'd crack from the steam pressure. So they go into drying chambers, long, warm tunnels where hot air gently removes the moisture. This can take anywhere from a few hours to overnight, depending on the tile size. By the time they leave, the tiles are completely dry and ready for the big heat. The firing stage is where these lifeless chunks of glass and clay turn into something you'd actually want on your kitchen wall. The tiles are loaded into tunnel kilns, basically giant ovens the length of a city bus. Slowly, they move through zones that get hotter and hotter until the temperature reaches between 1,500 degrees and 2,200 degrees Fahrenheit, about 800 to 200 degrees Celsius. At these temperatures, the glass particles soften and fuse together into a solid mass. Pigments wake up, revealing their final, vibrant colors. Any larger decorative chunks melt just enough to bond with the rest, creating smooth, glassy patterns. The factory controls the firing time and temperature down to the minute. Go too hot, and you lose the color. Too cool, and the tile stays brittle. When the tiles leave the hot zone, they can't just be dumped into room air, they'd shatter from thermal shock. Instead, they pass through an annealing section, where the temperature drops slowly over several hours. This gradual cooling relieves internal stress, making the tiles much stronger. By the end of this stage, they're cool enough to handle, and they look completely different from when they went in. Smooth, colorful, and solid. Some tiles go straight to packaging, but many get extra treatment to make them even more beautiful or practical. Polishing for a glossy, mirror-like finish, texturing for slip-resistant surfaces, perfect for bathroom floors, glazing to add shine, depth or patterns. The finishing line is where tiles really show their personality. It's also where quality inspectors check for chips, cracks, or color issues. Anything less than perfect gets recycled back into the process. Finally, the good tiles are stacked into cardboard boxes, cushioned to prevent damage, and labeled with size, color, and batch number. The boxes are loaded onto pallets, shrink-wrapped, and rolled onto trucks. Some will head to local home improvement stores, others to high-end designers or export markets. From here, they'll be installed in kitchens, hotel lobbies, swimming pools, anywhere a beautiful, durable tile is needed. It's proof that with the right technology and a little creativity, even broken trash can be turned into something beautiful and lasting. And that's the incredible journey of how broken glass gets a second life as beautiful, durable tiles. If you enjoyed this behind-the-scenes look and want to see more amazing transformations like this, make sure to subscribe and tap the bell icon so you never miss a new video. Thanks for watching, and I'll see you in the next one. Every part is tested, every function verified. From welding sparks to rolling off the line, it takes over 40 hours to build a single unit. Made in America, built to last, trusted worldwide. Today we take you inside John Deere's advanced manufacturing facility in Waterloo, Iowa, to see exactly how these machines are assembled from start to finish. No fluff, just steel, skill, and smart technology. This is how it's made. John Deere tractors. Before it became a global leader in agricultural machinery, John Deere was just a blacksmith. In 1837, in the small town of Grand Detour, Illinois, Deere invented something simple, but revolutionary: a polished steel plow that could cut through the thick, sticky soil of the American Midwest. Farmers were struggling with traditional cast iron plows that clogged easily. Deere's innovation didn't just solve a problem, it changed agriculture. As America expanded westward, so did demand. Deere moved operations to Moline, Illinois, harnessing water-powered factories and railway connections. The company grew fast, not just in size but in reputation. By the early 1900s, John Deere had become synonymous with reliability. In 1918, the company built its first tractor, the Waterloo Boy, a name that still echoes in Iowa, where many John Deere tractors are made today. Through 2 world wars, the Great Depression, and the rise of precision agriculture, John Deere kept evolving. It introduced diesel engines, power steering, 4-wheel drive, and eventually, onboard GPS and autonomous navigation. Today, John Deere isn't just building tractors, it's building smart machines that help feed the world, while staying true to a simple idea: tools should work as hard as the people who use them. From a one-man forge to a global powerhouse, the journey of John Deere is built on steel, sweat, and something stronger than both: trust. The making of a John Deere tractor begins long before any welding sparks fly. It starts with materials. Thousands of tons of high-grade carbon steel delivered by rail to the company's manufacturing hub in Waterloo, Iowa. This is the backbone of every tractor: tough, dense, and engineered to handle decades of heavy field work. Steel coils are unloaded, stored, and later laser cut into precision shapes, everything from chassis frames to transmission housings. But steel is just the beginning. Massive tires made from reinforced rubber are shipped in from partner plants. Hydraulic cylinders arrive pre-tested, ready to power lifting arms and steering systems. Aluminum components for the cab interior are pre-molded and lightweight, chosen to balance comfort with fuel efficiency. Electronics are sourced globally, but calibrated locally. Each tractor contains dozens of sensors, control units, and wiring harnesses, all built to survive dust, mud, vibration, and temperature extremes. At the heart of it all is the PowerTech diesel engine, made in-house by John Deere. Once the raw materials arrive, the first major transformation begins, turning flat steel into a tractor's structural backbone. At the chassis fabrication zone, sheets of carbon steel are fed into CNC-controlled laser cutters. Guided by digital blueprints, the lasers slice each piece with sub-millimeter precision, forming mounting plates, axle housings, and load-bearing crossmembers. These components are then moved to a series of robotic welding stations. Here, mechanical arms grip, align, and fuse them together using MIG welding, a method that delivers strong, consistent seams with minimal distortion.